Hello friends, in this series, in the earlier videos, we understood what is population variance and what is sample variance, right? Sample variance. So our population variance, we denoted that as sigma square, and sample variance is S square. Okay. Now, if we study about the econometrics model, how to write it? So this is our yi equal to beta 0 plus beta 1 xi plus epsilon I, epsilon subscript I. Okay, so this is our model. So in this case, the earlier equation that we had, summation xi minus x bar whole square divided by n minus 1, it will not work here, okay, because now we are having both x and y values. Okay, so in this case the formula will change. Okay, and another thing is, if someone says to you the variance, that is sigma square, is equal to the variance of the error term, and this is also equivalent to variance of yi. Okay, understood? Now the formula here will change. Now what we do here is sigma square, that is the population variance, is unknown. Okay, we will not be able to do that. So what we do is, we will not be know the population variance, so we use sample variance. Okay, to calculate the sample variance, we calculate the estimate of population variance actually, which is your sample variance. So that is equal to S square is equal to summation I goes from 1 to n times yi minus yi cap. Okay, yi cap, that is the predicted value. So we are actually taking the difference between the observed value, which is yi, minus the predicted value, that is yi cap, and then divide that by n minus 2. Okay, now the question is here n minus 2. Why 2? Earlier we did only one case, so it is negative. Here we are deducting 2. This n minus 2 is the degrees of freedom, and 2 is the number of number of parameters in the model, that is beta 0 and beta 1. Okay, similarly, if you will have more than 2 parameters in the model, then you have to use that variable. Like if you are having another variable, that is zi, and then it will be beta 2 zi. So beta 2 will be there in that model if you add one new variable zi. So in that case, that will become n minus 3. The degrees of freedom, it will become n minus 3. Now, so this is how it looks like. Now this yi minus yi cap, this is what? This is actually the sum of squared errors, okay, or sum of error squares. Okay, so instead of writing that s square, what we can do here, I'm rewriting this thing. Summation I goes from 1 to n s square equal to and yi minus yi cap whole square divided by n minus 2, and this upper part we can denote it as the sum of ei square. Okay, I goes from 1 to n and n minus 2. Okay, now this summation epsilon sub I square is nothing but your SSR. Okay, sum of squared residuals. Okay, and it is also your ESS, sorry, RSS, not ESS, sorry. So it is, you are writing is n minus 2. Okay, now this is also we can present as deviation, right? Deviation, the numerator part is known as the deviation from the mean predicted value, and the degrees of freedom in the denominator. Okay, degrees of freedom. Okay, so this is also known as the entire term, that is SSR divided by n minus 2 is also equal to MSE, that is mean square error. Okay, mean square error. Okay, so the entire term, that is SSR or RSS divided by n minus 2 is our mean square error. Okay, so you also can write it as MSE equal to sum of squared errors divided by the n minus 2 mean square error, and that is giving us the unbiased estimator. So expected value of S square is equal to sigma square. Okay, so this is the estimator of the variance. Okay, fine, we'll meet in the next video. Thank you.